Hello everyone, welcome to Dnyanadeep. In this UPSC simplified series, we are once again presenting you with UPSC mains geography question. Here is the question: define mantle plume and explain its role in plate tectonics. Again, this particular question is a very core geography question, typically related with the topics of plate tectonics and volcanicity. Now, this is a straightforward question, so there need not be a lot of complexities you need to introduce. So whatever has been asked, just put simple and straight in your answer. So first we'll try to address the introduction part. In introduction, you can go with a definition based approach and a fact based approach. So if I have to go for a definition based approach, directly I will define what these mantle plumes are, right? That is what something also is asked here. So in definition, you will define what these mantle plumes are, which are nothing but the flow of magma or currents of magma which are coming from core mantle boundary, right? And there is a lot of volcanic activity on the surface level as a result of these flows of lava or current of lava, and this is nothing but mantle plume is, right? So this is simple straight definition I'll put right at the beginning of my answer. This is one way to start. A lot of people can also go with any facts such as where we find these mantle plumes. This can also be your fact based introduction, but since it is a direct question, what I am going to prefer a definition based approach, right? So directly you are hitting the bullseye. So having defined it, now next question arises: should we explain what these mantle plumes are? Now that depends for how many marks this particular question has been asked. Typically this question was asked for, I guess, as far as I remember, it was asked for 10 marks, 150 words. So in that particular case, I need not be explaining a lot on what these mantle plumes are. I will simply define a crisp and clear definition of mantle plume, which I have recently provided. At the same time, I will also draw a diagram. I will draw a diagram, show core here or outer core here, and I will show the currents of magma which are rising, and these rising current of magma will erupt or result into a lot of magmatic eruption or lava eruption at the surface level. So this is nothing but my mantle plume. Have a well labeled diagram in this particular case, which is very, very essential. This is the diagram which is associated with what? The mantle plume part, right? I have defined it and presented it with a diagram. So first part ends here itself. So maybe in 20 or 30 words you are done. Now you have to go next for the explanation, and you have to provide the role of mantle plume in plate tectonics, right? Now again, this is a very typical core geography part. In very few books or very few resources, this particular part is given. Now when it comes to explaining the role of mantle plume in terms of plate tectonics, I have divided my body part into two parts. First part, I am going to address, see, these mantle plumes, they result into hotspot volcanoes, right? So wherever we find hotspot volcanism, now I hope you all know what these hotspot volcanoes are. So whatever hotspot volcanoes we have, they are strictly associated with mantle plume, or they are the result of mantle plume. At that particular point, wherever we have hotspot volcano, there are two features we find. One is continuous eruption, maybe for last crores of years. At the same time, the location of eruption is same, right? The location of eruption is not going to change at all. Okay, so permanent fixed location is there for hotspot volcanoes, and there is a continuous eruption. Now what happens as a result of this continuous eruption? Generally we find hotspot volcanoes in oceanic areas or at the surface of the ocean. So we have mantle plume, rising lava at the ocean surface. Oceanic surface is a very thin oceanic crust or thin crustal part. This rising plume or rising limb of lava, it will result into breaking of this particular oceanic crust. And here is its relation with the plate tectonics. Now, wherever you find that oceanic crust has broken into two parts, or wherever you find that there is a divergent boundary. So, where did this divergent boundary evolve? It typically evolved at the location of hotspot volcano, or where we have mantle plumes. So, what I am trying to suggest, I'm just trying to suggest that these mantle plumes are responsible for the divergent boundary, or in other words, I can say these mantle plumes are responsible for breaking of continental crust, right? I'll say these are responsible for breaking of continental crust, and as a result of breaking of continental crust, from there we will have a divergent boundary. Now, how and why this is happening? Just take example of a rigid surface, a rigid glass surface. Now, what happens with a rigid glass surface or any crystalline surface? If I break glass at this point, this is applicable for a glass, this will also be applicable for a large slab of rocks. If I break it at one point, what happens? This crack will develop and it will go forward. So what these mantle plumes or hotspot volcanoes do, these hotspot volcanoes, see, if here, let's draw one more surface. If this is the oceanic crust and we have the hotspot volcano somewhere here. So what hotspot volcano will do or mantle plume will do, it will start to rupture or it will start to break this surface somewhere near the hotspot volcano. And from this point, we find that whole of the plate or whole of the surface is ruptured and split into two parts, right? So that is how these mantle plumes are resulting into the breaking of oceanic crust and resulting into formation of divergent boundaries. So this is one part. Now, once we have divergent boundaries, right, along this divergent boundary, a lot of magma will flow in on the surface and we will also have seafloor spreading. Now, seafloor spreading is not as directly related with that of mantle plumes or hotspot volcano, but I'll just extend. I'm just extending from here. Now, original or whatever the part of the answer I had to address, it would end at divergent boundary. But what I'm doing, I'm just extending this part and also saying, you see, wherever now we have divergent boundary, there is seafloor spreading takes place. And that is how we have motion of plates. So this way I complete the addressing of the role of mantle plume in that of plate tectonics, right? So this much part is enough. If you have explained the concepts well, you do not need to fill pages. It may also happen that you will introduce in 20-30 words with definition and you will take next maybe 70 words to explain the body part. It's fine. You have reached 100 words. You have drawn one diagram, and in that diagram, what you have shown what mantle plumes are. Now, you also have to do one more thing. You have to show it on a map. I think this map is in a faded form. So, on a map, show two things. One, hotspot volcanoes, and another thing you need to show will be divergent boundaries. Now, it may happen that you do not know a lot of divergent boundary. Maybe one boundary you can draw is this mid-oceanic or mid-Atlantic ridge. There we have divergent boundary. Here we have one hotspot volcano, that is Iceland. Show this hotspot volcano. Now it sits on divergent boundary, so that way you are also explaining how this hotspot volcano is resulting into the formation of divergent boundaries, so on and so forth. Fine. So this is how I am completing my part where I am addressing the role of mantle-plume in plate tectonics. Now in conclusion, you will have a very generic conclusion. One way I can say that this is a very important geomorphic process and it plays a crucial role in the process of plate tectonics. That's a very flat generic introduction. Another way I can say that this mantle plume results into hotspot volcanism and other geomorphic processes and landform development. In that I can say that there is a formation of volcanic provinces, basaltic provinces which are forming maybe at the sea floor or on the surface. So I'm also telling the impact of mantle plumes, right? So both way you can conclude, you can have your choice in this particular part, but conclusion in this particular question is not going to be as fancy as you will expect in other part. Fine. So that is about the question on mantle plume. So thank you everyone. We'll see you in next session.